Hello everyone, so I'm Jeremy Chapman. You probably have seen some of my videos on Microsoft Mechanics, and today we're going to talk about the real mechanics of AI and some of the innovations that we make along the way with various parts of the things in the Copilot stack that we have across Microsoft. This session was billed as an Azure session. There are Azure components to it, but there's also a lot of Microsoft 365 in it. So if you've not seen any of the work that I've done, I'm Jeremy Chapman. I have been working at Microsoft now for just over 20 years as of January. So before that, I was in IT. I've worked in Europe. I've worked in mainland China and came over to the US or back to the US in 2005. And I've been at Microsoft basically ever since I came back. So I've been doing Microsoft Mechanics since 2013 or 12, maybe the ends of 2012. So it started out being the Garage series, and then we kind of went into the mechanics mode when we started to go out beyond Office and various other disciplines and other product groups. I think Surface was the first non-Office product team to join, then we had Azure, and Windows kind of came in last. And I did a Windows demo this morning, so it's kind of interesting with that. But I was in Windows prior to going to Office. So what I want to do is actually take the next hour and go through some of the things that make Microsoft's AI platform one of the ones that you'd want to kind of bet your AI bets on, because not only are the large language models that we're using across the board things that are always evolving, always getting better, always kind of giving you the latest, greatest there, but all the things around it, around the periphery, around the platform itself, I want to show you what has been done there, because a lot of smart people have worked on everything from the silicon to the data tier, the logic tier with orchestration, up through the Copilot tier in terms of the app interface, security and compliance, and all the things that you've seen a lot of that today already. I'm going to explain all of that with additional context here today. So I want to start out with a demo. So I do a lot of video. So you guys probably know this. I do a lot of video for Microsoft Mechanics and other things. What I wanted to do was create a multi-agentic video that was narrated. We're taking multiple parts. Now that we have things like Sora, we can actually take multiple pieces of video together, stitch them together, and add audio narration. And so to do this, though, right now, you do need something to do orchestration for you. So semantic kernel is the way that you're going to build these types of multi-agentic apps typically. So this is the raw semantic kernel code that basically stitches together a coordinator agent with a prompt kind of agent to write Sora prompts, going out to Sora for video creation, and using an MCP for bringing the video pieces together. So the different pieces that we have here are just GPT-4o for basically writing your prompt, and then creating the different Sora subprompts in order to be able to get videos generated. Then using speech, or text-to-speech, I should say, to be able to narrate what was generated by the first prompt. Then uploading photos as part of Sora API to be able to prompt it for what to create. Then we'll use an MCP, a content plugin effectively, to be able to run FFmpeg, which is an open source tool to do video editing with command line, so you can automate that. We're concatenating multiple videos together, adding the audio track to that, and then creating a video output. So anybody want to see what the first video looks like that we built using these kind of things? That was kind of more polished, I would say. I'll give you a preview of that here. I need the audio.
The hybrid SUV engineered for the untamed, rugged, versatile.
I'll start one more time just so we get the beginning of the audio.
Introducing the Contoso Earth Pilot. The hybrid SUV engineered for the untamed, rugged, versatile, and built to handle whatever the wild throws your way. Upgrade to the Ovalanda option package and turn every outing into an escape with a rooftop tent, onboard power, and all-terrain capability. The Earth Pilot isn't just transport, it's your gateway to freedom. Go anywhere. Escape everything.
What do you think? That was not bad, right? We're either witnessing something really powerful or like the downfall of advertising right in front of us. Okay, so the thing is you can build things like this now, and I'm going to go through kind of what that means and go through the entire Copilot stack. Now, the Copilot stack, you've probably seen this slide. Satya presents it a lot at, say, build conferences, but basically, you think about the metal, the infrastructure that runs it. the foundational models that are kind of running the themselves, your data. So there are a couple different data ways to get your data in. There are data tiers that run. For example, Cosmos DB is the data backend that runs all of ChatGPT at scale globally. There are other things that you can do with data, like retrieval augmented generation, fine-tuning. Then we also have AI orchestration and toolchain as part of the end-to-end story, and then Microsoft Copilot, as well as agents that you can build, and finally, the AI safety and security layer. So I'm going to go through all those different things with highlights around different engineering problems, and then how we actually made those better. So we think about AI infrastructure first. Now, AI infrastructure is basically the key to why all of this is happening, why all of this is working. You see, not too long ago, in the last decade, we've been able to basically take multiple GPUs, network them together using fiber optics and InfiniBand, also take CPUs, AMD CPUs specifically, and create effectively what is a supercomputer with 10,000 plus connected GPUs and 10,000 plus connected CPUs. Imagine like your best gaming rig you've ever purchased at home, or anybody that you know, and taking 10,000 of them to make one physical unit, to where the VMs, the hypervisor, sees it as one computer. That's what we're able to make. That's why we're able to build these massive models that have sometimes up to 1 trillion parameters. So this is all running in Azure. So basically, you think about the data center footprint that we have, being able to run basically eight different GPUs simultaneously on the same server that are connected themselves as if they're one unit. Then being able to use fat tree networking and Multinex cables and InfiniBand itself to be able to connect up to 10,000, 14,400 was the training computer size for GPT-4o. And then you add to that the hypervisor layer, the virtual machine layer, all the different manageability, permissioning, the different runtimes for Onyx and DeepSpeed to be able to accelerate AI. These are all things that are running not just for training, but this is stuff that you're using to run inference as well, the things that are running Copilot services, for example, as part of Microsoft 365. So not only does all of this work accrue to being able to train these massive models, but it's also how we operate our own services. Now, just to go into networking the GPUs and CPUs, to give you some kind of speed metrics and what it means. So if you think about an NVIDIA server, for example, a rack that has all of the GPUs in it, the data centers that we have will have multiple racks that will have multiple server blades, obviously, that are running 8 or more GPUs per blade. And when you connect those up together on the same board, they're extremely fast using NVLink, which is the kind of NVIDIA version of InfiniBand that runs on board, on package. And that will give you incredible speeds in terms of being able to communicate the cross-sectional bandwidth between the GPUs. So you want it, again, to live and breathe and feel like it's one machine. So that will give you speeds effectively up to 3.6 terabits per second. What is 3.6 terabits per second bisectional bandwidth? If I were able to copy 99 Blu-ray DVDs in 1 second, that's 3.6 terabits per second. And then when you take all the nodes, and there's 8 nodes per server times 400 gigabits, you have 3.2 terabits per VM node that's running Azure Kubernetes Service effectively to run all of the compute required to get these models built and trained. Now, because it's so massive, and these models that we're training are taking sometimes up to a month or more to be able to train them, you also have to build load balancing tools to be able to pause, or if something goes wrong in the training, go back to a previous snapshot to not lose progress, because the last thing you want is to go 3 weeks into a 4-week training cycle, something bad happens, and you lost 3 weeks of training data. So we've also had to solve for that. So that's where our current naming for that, it used to be called Project Forge, now it's called Project Manifold. I don't know who's coming up with all the naming, but Project Manifold basically allows us to take training of these larger models that we have, OpenAI models effectively, as well as our own internal models. If something goes wrong, we've got snapshots along the way that we can reapply. And because they're so massive, you also have to load balance in terms of demand that you're offering to various services for inference and other training jobs. So you have to be able to pause and then move them between different data centers. So these are all things that we had to build for around GPU scarcity effectively, because you have to schedule and time all of the GPU training cycles, inference cycles, etc. And along with that scarcity means that you have to be able to write code that will work across your AMD, NVIDIA, and even our Maya GPUs that we use for our own internal workloads right now that we're starting to offer out more for public consumption. So if you think about our stack, so we have all the way up at the very top, we have our applications, things like Copilot or also ChatGPT, your large language models, your AI frameworks, PyTorch and Onyx. Then you have the kernel libraries that if you're actually writing to the metal, you're using CUDA, you're using ROCm from AMD, or using our own Maya. Now, all of these different things are letting you get the most performance possible, basically, out of the code that you write, being able to go directly into these kernel libraries. So what we're building, basically, is an interoperability layer called Triton in cooperation with OpenAI that says, I want to be able to, even if I don't have NVIDIA GPUs handy, or I've got older generations of GPUs, I want to write one code base and be able to swap in and swap out the GPU that is available, right? Because that way I can run inference, that way I can run model training, other things across other GPUs and other locations and other regions. And that's something else that we had to build as well. So now moving on to foundational models, one of the things that you've probably seen with foundational models is the size of their parameters and how they grow. So if we think about something like GPT 3.0, for example, this is a model that started out with a lot of parameters at the time, 175 billion. We had our own Microsoft Megatron Turing model. You get the transformer as the T in GPT and the Megatron naming, which is fun. Now we're getting even bigger to where we don't publish the amount of parameters that are in the model, but they're massive. They're over a trillion parameters at this stage in terms of the larger models. So the one thing with models, though, is that not everything means that because you add more, that it's going to be better all the time. So the models themselves are kind of generalists. So think about, there are ways to do things like model distillation, model fine-tuning, which I'll get to, that give things more specialist or skilled knowledge as well. So when we started building out these smaller large language models or small language models like Phi, that gives us the ability to run models that have, say, 3.8 or even less than that on Copilot Plus PCs like I've got here, so I can run these models locally on smaller devices. And if you compare that to kind of the larger models like Llama 3, 70 billion, which we use a lot for benchmark testing, and also GPT-3 at 175 billion, these smaller, like single and double-digit billions of parameters are actually quite compact in terms of what they can do. And a lot of them have the quality of response, the recall, that some of the bigger models like GPT-3 had at the time. So you can actually, from a smaller model, get the same type of completion and performance and response as some of the bigger models, just based on the pure fine-tuning and distillation of what's in the model itself. So that kind of brings us to how do we have to solve for data. There's a couple things that we have to solve for from a data perspective, right? One of them is currency and specialization of data. Not everything is in the training set for data. So you have to have the ability to look up the right data, get the right results, and then that will give you either more currency, more up-to-dateness, because the models might be trained 6 months ago, a year ago, 2 years ago. If anybody ever used like ChatGPT, in the initial year, it would go back to September 2021, I think, in the beginning. So you'd ask it like, what's in the theater? What movies are playing? And they would say like a movie that was 2 years old, and of course it's wrong. When you're using RAG, or retrieval augmented generation, that solves for the currency of information, the up-to-dateness of information, and it can also work to help you find information that you need that's not part of the training set. So anything Copilot is going to be using this. It's going to use a combination of things, and traditionally search was done using keywords, where you'd find keywords and or keyword synonyms that was kind of limited. But everything now is based on vector search. So what is vector search? Well, vector search operates on a concept of cosine similarity. Any embedding, any vector that you have has between usually 1,500 and 3,072 different dimensions that describe what it is. So that means I can take things that don't even have the word present in the search and find things in the database that are similar, not the same, but that's using that cosine similarity to say, for example, the lion roared loudly versus the king of the jungle. Lion and king of the jungle aren't the same word. So keyword wouldn't have found that. That's where vector similarity comes in. Now you want to take, though, both of those concepts, the keyword as well as vector similarity into the same search result. So for example, if I want to look for a part number, I want to be able to find the part number based on keyword search. I don't want it to hallucinate and find some other part number that's related. I want to know exactly that, so you need both of them. Now the other trick to this with vector-based search is you need the prompt itself to be converted into an embedding, into a vector format, so that it can actually do lookups against the database. So you have to build all of that, and that's going to be, I think, one of the areas of opportunity later, because right now, a lot of these things are speaking different languages. You have things like Ada 2 and Ada 3 embedding models from OpenAI, which is what, for example, Azure AI Search uses and ChatGPT uses, but if I have a vector index on Ada 2 or Ada 3, my prompt has to be converted into that as well. So that means you have like incompatibilities between your search prompting and your vector indices that can cause problems later. So I think that's going to be an area where we might hopefully standardize in terms of how we do embeddings and how we do searches with vector-based search. So from a hybrid search perspective, what we want is to be able to take the keywords. So we want to, in this case, take lion, because we want to find like, where is lion? And we want the similarity search part of that to be able to say, okay, I have semantically dissimilar topics here, the apex predator versus the thunderous sound, but it's both got lion, where I want to have basically both of these concepts in. And even though the first two results are the closest, they don't both include the word lion, that's okay though, because that's the better search result, because we've ranked the keyword along with the vector-based semantic search result. The cool thing is a lot of this was only relegated to the Copilot prompt and what Copilot could search with, and now with the new updated search with Copilot search, we're actually giving that to you as part of what you can do through SharePoint or other search endpoints as well. All right, so then you have the problem of how do I create the embeddings based on all of the content that I might have in SharePoint? I might have terabytes of data in SharePoint. How do I actually create embeddings in those 3,000 or so parameters to be able to search against? And so what happens in terms of embeddings creation is we take documents and we take them and chunk them out, and chunking is actually the technical term, into smaller documents, and documents is another technical term, and those are actually computed as an embedding. So maybe at a sentence level or a paragraph level, depending on the size of it and the theme of what you're actually creating the vector embeddings based on. Then we put that in a vector database, and then again, any prompt that you write has to be converted into an embedding to be able to show the results for the matching prompt that you have plus the result in the database. So these are all things that we had to develop and build, and these are all things that the LLM uses, by the way, to find information as it creates your responses. Okay, so then you've got your index size problem, because as you'd probably guess, I have 3,072 of these numbers that are usually somewhere in the 10-digit long range. They're usually like 0 point something something negative or positive, pretty long. And if I have 3,000 of these per embedding times millions of embeddings, that's going to grow pretty massively. And so what we had to do initially is we would put the index in RAM for being able to do search lookups, because RAM is fast. And so you'd have this index problem where, what if my laptop, like this one, which has, I think, 32 gigs of RAM, doesn't have a terabyte of RAM, because I can't store my entire graph there. And that's another thing that we actually developed through Microsoft research called disk ANN, disk approximate nearest neighbor. So there's basically, think of it like there's two different graphs. There's like the baby graph, which we call as the quantized graph, and that has a smaller subset of basically the dimensions in it to be able to point to the full precision vectors that are on the solid state drive. The nice thing with solid state drives is that they're getting faster and faster, almost to the point where they're almost as fast as RAM was a few years ago in some cases, and some SSDs actually use RAM speed memory in them for storage. So that gives you the ability to have basically smaller indexes that can be searched quickly in RAM and memory that can then point to full precision vectors that are on the SSD. So that unlocks, again, another way. For example, this Copilot Plus PC supports disk ANN. It supports vector-based search through File Explorer. It supports all of these things. It has a large language model for image embeddings, calculation, and lookups. That's how recall works. That's how things like the file-based search works for images or for text, looking through File Explorer, for example, with semantic search. All of that is being done through these types of models. Then there's another approach that you need to know about, which is retrieval augmented generation, or RAG. Everybody knows what retrieval augmented generation is, RAG? A lot of people probably should. So basically, this is the concept to say, I need to find information that sits outside of a prompt, and I'm going to point it to additional data sources. So for example, let's say I asked it right now, what's the weather like today in Las Vegas? And if I asked it what the weather was like today in Las Vegas, it wouldn't know because A, there's no current information in large language model training because it needs to look to a weather report. B, it would probably guess and say, it's 90 degrees and no humidity and desert-like crazy conditions and really hot. Because it would look at like previous years probably, right? So what this gives you with retrieval augmented generation is the ability to basically do a lookup against data sources that you do have access to, find semantically and or keyword similar topics, add those to your prompts, and now you have the prompt, what's the weather? And then it's like, the weather is it's raining and 70 degrees or whatever it is, added to the prompt so the LLM knows because not only does it have your question, but it has the answer to your prompt in that data set as part of the retrieval. So now it can give you a nice response, a nice completion that says, oh, hey, Jeremy, it's 70 degrees and raining right now in Las Vegas. And the LLM would never have known that using its own training because it doesn't know, it would know, like, again, trends, but it wouldn't know what's happening literally right now. All right, so then you've got fine-tuning. Everybody know what fine-tuning is? A couple people know what fine-tuning is. So fine-tuning is the way to kind of simulate expertise or experience. What does that mean? So fine-tuning says, okay, I have an output that I do all the time. Let's say I write talk tracks for the Microsoft Mechanics. Let's say I write contracts or I write letters of intent or whatever, medical analyses that are kind of similar-ish every time. And there are certain things that I, as a skilled professional in this profession or in this organization, do every single time, and different checks that I make, different chapters that I write that are almost identical every time. So I can give it that additional information, that additional context as part of basically what sits outside of the LLMs or the large language models training. Now the thing is with these though, like I've got potentially terabytes of information, usually it's going to be smaller, but I've got either like a JSON-L package, which is usually what we use for fine-tuning with Azure, or I've got some other files that I'm putting into this fine-tuning data set. So the problem with that is I don't want everyone that's in my company to necessarily be able to see what's in that fine-tuned data set for that discipline of the company. Like I don't want my IT team necessarily to see what's in my HR system or being developed by our contracts team if we have a legal team or something. And I don't want another company who's sharing the same large language model and inference infrastructure, which is basically how all these models are running, to be able to see my data if I'm from Contoso and my competitors at Fabricam. They shouldn't see basically my fine-tuned data set, and the LLM can't be merged with that fine-tuned data set. So the way I think about fine-tuning in terms of the mechanics of it, no pun intended, if you ever built a virtual machine with differencing disks, you can have your base VM and you pile on differencing disks on top of that, and you can run them so they're all kind of in parallel to each other, and they're all doing completely different things. You have your base that you're kind of extending. You can merge the differencing disks just like you can with fine-tuning into the LLM, into the core data. But in this case, we want to be able to take fine-tuning and we want to make it so basically this low-rank adaptive fine-tuning data set stays its own kind of unique data layer. Think of it like a USB drive that gets plugged into the LLM. And so this gets plugged in, but you don't want anybody else to have access to it. So the engineering challenge here was like, okay, I only want the LLM to see it in my context when I'm interacting with it, but I've got to use something called multi-LoRa, multi-low-ranking adaptive fine-tuning, for other departments or other companies who are leveraging the same LLMs for inference to be able to add their data to it, but not see my data that I'm adding to it for my fine-tuning data set. That gives us the ability to do that. So as you start to look at things like fine-tuning, this is what gives you basically separation between your fine-tuning data in another departments or another company who is leveraging the same LLM inference infrastructure. All right, and that then takes me to orchestration. So reasoning is something that has always been happening since day one with Copilot. I will say that again. There's always been some form of reasoning. Yes, reasoning's gotten better, But there were days when we just want to say, like, all these things are happening when you submit your prompt, then magic happens. We're not going to tell you what's happening underneath that, and we're just going to give you a completion or a response. And you're supposed to say, wow, that's amazing, that's magic. But as you know, like from going to school, university, what have you, a lot of teachers, professors want you to show your work. And that's kind of, I would say, like, as we start to look in reasoning, and last January when reasoning became a big deal, is because it was showing its work. You go back 2 years ago to Security Copilot, it's always been showing its work and showing its reasoning. Let's see if devices were impacted by this virus or this vulnerability. Let's look at user accounts. Let's look at mail inboxes. Let's look at SharePoint sites. And it was doing that reasoning before. It was showing its work. Showing its work only became popularized really in the consumer space as of this last January or so. But it's always been there. So if you look at Copilot and kind of the orchestration, how it works now, and you've probably seen this, and I'll see if I can kind of trace the way that things come in. But basically you have your prompt that goes in through. There's a filter initially, which I'll talk about in a second, that filters things out, prompt injection attacks, etc., indirect or direct, goes in through the large language model or the Copilot orchestration service. It then looks to see if there is information that it can use to ground that prompt, if that prompt needs things that are outside of what's in the training set. Then it can go either outward to the web if you've got it configured to do that. It can look up and use actions if it needs to go out to another system, or it can go to the Microsoft Graph, which can also be connected to go to external connectors to be able to find information outside of what's core to Microsoft 365. That information is then parsed and sent back up through the orchestration back to the LLM, which the LLM says, cool, I've got enough information. Sometimes, guess what? It says, I don't have enough information. I don't like the search results, and it reiterates. That's part of the reasoning that was there the whole time. So then you'll get the reasoning of it. It'll look at, okay, I can respond to you. There might be things that either on the inward side, at the reasoning side, or on the outbound side that says, hey, no. There's no information, you don't have access to that, or that document has a label on it, or it's got classification, whatever. Those types of things will get flagged and or kind of automatically labeled or set. Then finally, once it's done everything, it's looked at, for example, the different filters. If there are different filters around like self-harm, violence, etc., it's actually looking at those things as part of responsible AI, sending you back, and there's one last filter here before it comes back at you, and then it returns to the app. So there's multiple different filtering phases that happen through this. So that's kind of how we're using basically orchestration as part of Copilot at a very high level, but it's reiterating a lot of times. It's going back and looking for more information. Then we have prompt flows, and the prompt flows basically are saying, okay, if I want to build my own Copilot-like orchestration, I can do that either using what's in Azure AI Foundry. I can do things like use a semantic kernel like I showed before, LangChain, AutoGen, those types of things. In fact, I have semantic kernel because that was what we used to actually build the ad generating service as the multi-agentic thing that will do orchestration as well, and kind of simulate basically what Copilot can do in terms of how it's finding information, orchestrating the results, etc. All right. So that's kind of key to being able to do these things that are actually bringing together multiple results. So now that I've talked about, now we've got to accrue all of this stuff into what it means from a Copilot perspective. Now, truth be told, I used to always think when I heard Copilot is the UI for AI, it sounded like marketing. My dichotomy of my role is weird because I'm technically in a marketing team. I came from an engineering background, an IT background, but I've got to explain things to technical people like yourselves who don't like marketing. That's my burden. So, it is actually that though. Like a lot of times you'll have the intent, especially when you look at GitHub Copilot. I want to build a console app that does X and uses this information and connects to this API to go out and get that. I've just, without even using any UI, I've just described what I wanted intent-based, and it's gone and done that. Imagine when you get there in terms of building your own agents and building your own processes where you don't necessarily need the user interface, or it's only like 10% of your battle versus like 90% in WYSIWYG days, where what you see is what you get is spending most of your time trying to build what you want from a user interface perspective. Copilot's kind of making that part a lot easier, and there are even tools that will build interfaces for you that are AI generated. So Copilot is actually the UI for AI, because if you start interacting with text only, or verbal prompts, etc., or pictures, all of these things can basically build stuff for you without you even having to interact with that user interface. All right, so that then takes me to kind of how does all this stuff come together? So Copilot demos, and I've got a couple here, it's always like the hardest decision because there's Copilot experiences everywhere in every app. So a couple of my favorites, and these are things that, that I built as part of mechanics, but one of the favorites is parsing a really, really, really terribly long email. I get one of these at least every day. I get added to the end of it. Hey, there's a customer escalation that I went for like, whatever, 16 turns. I'm added and they want to do something. I have a question about something. So this is one of the best use cases, and I would say the Outlook team has done a great job in terms of its iterating and getting better and better and better over time. But this email, it literally has like 10 pages of mail on it. And so if I say summarize this, literally, this is all the information that I need to know about this entire email chain, which is these 4 bullets. Now this is like hours per day kind of saving stuff. And granted, this is one slice of how you can use Copilot, but this is a major thing. So now beyond that, we've got all the different experiences across Copilot. Actually, I want to show you something else. One sec. If it will let me. I'll play through. I don't have the immediate controls on this one. But after it does the distillation of the different bullets in the Copilot, using parsing your Outlook, one of my other favorite ones is the one that we saw this morning, which is using Teams with Copilot. Anybody here using Teams with Copilot? All right, so that one, I got to say, that was a no-brainer kind of application in the beginning, because I am always double booked. I'm always 10 minutes late to meetings. Now it doesn't really matter too much when that is the case, because you can always go back and see what happened and what you missed. But it's gotten even better, because now when you go into a Teams meeting, not only can you arrive late, I probably shouldn't promote arriving late to meetings if you can avoid it, but not only can you arrive late to a meeting and see what you missed, but even if there's shared screen content, which is like 90% of my meetings, there's very rarely a meeting that somebody's not sharing their whole screen or a PowerPoint or something, I can go in and I can say what screen content was shared that I missed. And so this one, just being able to look at the slides that were there and see the actual screen content and have it referenced as part of the completion is just amazing. I will use this for note-taking when I'm trying to summarize what our action plan was, or demos that we actually want to interlace inside of a mechanics episode or something. Again, these are hours per day kind of saving things that I'm using all the time. That's why I wanted to include those, because there are some other new things that I want to show, and I'll hold questions for the end. But these are all things that I do a lot myself. Of course, there are Copilot experiences across the board in terms of all the Microsoft 365 apps. And I'll show some more things in a second, which are basically the other updates that we just recently announced on the 23rd of April as well. So, agents. Now, agents are interesting because you can build basic agents, which basic agents are effectively saying, let's, from a department, point this to certain information or certain data, which is typically going to be a SharePoint site, but not always. It can be other things. They're usually graph connectors, though, at this stage. Actions, though, are where you use APIs or use MCPs later to be able to connect to things that can do read and write. Knowledge is usually a graph connector, which is doing a read to external data or to internal data in Microsoft 365. It's still following the normal pattern reg concept in the sense that it's finding information that it can look through SharePoint or your calendar or other things that are wired into it. The internet, and it's augmenting prompts, sending that to the large language model to get the completion. With Microsoft 365, the way to basically do read-write activities through actions, that gives you the ability to look at something, maybe the status of a service ticket or something if you're in IT, and then actually write status back to it like it's pending or it's being serviced or it's been resolved or those types of things. So you have now the ability to not just get knowledge and use knowledge, but you have the ability to perform actions. But with knowledge, you're kind of connecting to the graph. You're connecting to different sources that you've permitted the graph to look at. that basically the graph creates its own additional indices around the connected content. So when we see search right now that's basically connected and it's going to Jira or other services that we've shown through Copilot Search, for example, those are all using graph connectors right now under the covers. And all of this means that you can create your own agents with your own actions and your own knowledge, and you have the ability to do some pretty powerful things here. And I'd say actions, watch out for actions. There's going to be a lot more things to come with that because it gives you the read-write, not just the read, but the write functionality to do even more automation. Now, multi-agentic solutions are interesting because, A, each agent is doing reasoning, but how do the different agents actually work together in order to reason over content and build out content or build out responses that use all the different agent interactions? So one of the most highly demoed set of multi-agentic agents that we do is we do a report writer, or basically we have a researcher agent that goes out to the web or goes out to an internal knowledge source, gives that information to a writer agent that's kind of been fine-tuned to write information. The writer agent then writes that, and basically an editor agent says, I like or don't like that. And all of these different passes, all of these different turns, they can feed back to each other and say, I like or don't like, or I want you to work more on, say, the researcher or the writer, all those things. I'd say with the exception of the sender agent, that this is one of the things where semantically, by the way, not everything's an agent, even though we call it the sender agent. If it's just doing a discrete task, you can just call that a task. If there's no reasoning happening, then I would say, or a lot of people will say that's not an agent. So let me show you a couple of agent demos, because is anybody in here on the Frontier program for analyst or researcher? This is where things get really interesting. So I'm going to show you a couple of different demos. So, and I've tried not to speed these things up too much, but sometimes these will run 14, 15 minutes in a researcher. So I've tried to make tasteful cuts in terms of speeding some things up, but the analyst ones are more or less at real-time speed. So if I run analyst, and let's say I want to have it look at different insights around multiple large language models, and this is 100% running real. If you've got the Frontier tenant with the data in it, you can actually run this prompt right now. And it's going to go in and it's going to look for information that it has access to. Now, it does take a while. I mean, these things, when they run, they're not running super duper fast. These things are running and they're going and they're iterating back and forth, just like we saw in the multi-agentic system where they're saying, hey, do I have enough information here? And going back to the well and finding more and more information until they can actually make a decision. And then they're showing you along the way, here's what we're working on. Here's the Python that's running behind it, if you know how to read through Python and kind of assess its Python. And then it will, because you wanted, in this case, to create visuals, it will create visuals for you. So just to look at kind of all the things that it's doing. It's considering data sources, examining different things. It's looking at extraction and visualizations and looking and simulating and plotting data sets. All these things are part of the reasoning that's running. Again, we've had reasoning the whole time, but this reasoning is next level. This is a lot more powerful. Then it's saying, okay, so if I want to look at from a data perspective, what's the Python that I'm running against that? Gives it to you all completely. It's showing its work. Again, another concept that is accruing back to Copilot here in this case with an agent. And it's actually building out visualizations, so you can actually see what it came up with. So not too bad. This is literally, and it ran probably in real time 2 minutes, 30 seconds. I might have trimmed 45 seconds off of it, but it's pretty quick on the analyst runs. The other one that's pretty neat, I think, is anyone else here a Formula One fan for racing? A couple people? All right. I'm a big F1 fan. I don't miss a race. I'll wake up at 3 o'clock in the morning because it's hard to watch them in the Pacific Northwest where we're way out of the time zone. So this prompt is to say, who are kind of how do different drivers compare, Max Verstappen compared to Vettel and Hamilton, and how do we, with the drivers' championship rankings, how do we kind of plot them along the way, and look at current races, the top 3, look at all of the different data that you can find on the web effectively here, and find different trend lines that match the legends, like Hamilton in this case, or Vettel. I would even go back, if I wanted to go back to Juan Manuel Fangio or Schumacher, for example, going back further. But this kind of stipulates the ones that they want to compare against. So it goes out in the web, and it goes and it finds all the information, and it shows how they stack up, and even kind of starts to do a little analysis of up-and-coming drivers like Russell and Leclerc and Lando Norris. But let's just go through what it did here. So here, It's gone and it's also prepared data collection for F1 sources, all the different data sources for rankings that it found on the web in this case, driver data and rankings, and simulated plausible driver championship rankings. And then it found kind of simulated ranking data as well for all these different drivers, and it's kind of stacking them up based on how their previous performances have gone and looking at different years of races from like 2000 forward across all these great drivers. And then it starts to map all of that out here for you in a line to show, like, you've got Verstappen, who's green here effectively, Vettel, who's in orange, and then you've got Hamilton, who's always been pretty consistent, you can see until these last 2 years, right along top in blue, where you can see kind of how they're tracking over time. So pretty cool stuff, and it found all of this information on the web, and you can also use Context IQ, or you can use your own like / reference material locally to also find information for Excel or other spreadsheets or other data that you want to include in this as well. Now, Researcher will run like 15 minutes in this one that I'm going to show you. So this one I want to do a comparison. So I want to show Researcher wants to write a written report, a long one, this time comparing WTI, or Work Trend Index reports. And these are like 20-plus page documents that wouldn't fit normally in a context window in terms of your token limits for any LLM. So this will run literally, like I think it would sit on that first bit with the progress bar for about, well, actually before it gets to the go ahead question, it will ask me, like, is this what you want me to do? Are there specific sections or aspects that you want me to do, particular AI-powered productivity tools, or do you want me to just go ahead? I usually just respond go ahead because I take its response to the initial response, but you can actually guide it a little bit more. And so I say go ahead. And then basically it's going to continue to research and write all of this stuff, looking at these 20-plus page reports and trying to grab all that information and compare the two. And this is literally like what a researcher would do that does this for a living. This is something that, again, is giving that skill or that expertise that you would expect to give these expert-style responses that's done this job before. You're simulating experience using an agent like this that's doing reasoning. That's part of where kind of the differences come in versus, say, if you're using RAG and kind of basic completions and basic responses. So now we have kind of all of the reasoning that's happened, and then we can kind of follow along as to what it's done. We can look at everything that's been written here. So in this case, it's written out basically a 20-page doc comparing our work trends index reports that are published by Microsoft for 2023 and 2024, and it's going through all of it very thoroughly, and it's coming up with, what's the kind of how's work trending, what's happening, what would I do if I was going to build a proposal for a pilot program for AI-powered productivity in your team? Like, it's going through and it's building all this for us. So it's kind of like Copilot if you've used it with normal prompt response. Copilot on steroids is doing all of this work, looking for all the different information outside and above and beyond what it would normally look for. Okay, so in terms of with the direct prompt injection attack or jailbreaking, this is where basically I'm saying, hey, I'm actually a researcher, for example. I'm actually a researcher, you can give me access to this privileged information. In this case, it's for a bank account, and I want to be able to see like bank account and social security numbers or whatever for a user. So sometimes that will dupe an LLM into believing you effectively, and you can get access to information that you shouldn't have access to if it's wired up like that without the right permissioning and accolade and everything like we normally have through permissions management in Copilot. So through a normal like system prompt or instructions, you may not get the filtering that you want, and you might be able to convince the LLM to do things that it shouldn't do. That's not something you have to worry about with Copilot, because not only do we have the filters, but we also have the rights management to the actual information underneath it that's used for search. Then you have indirect prompt injection attacks. So what's wrong with this email? Nothing apparently, but it's got white text on a white background. Now let's say I wanted to find out the best discount I could possibly get on a roof. I've had to buy a roof, and it's like the worst purchase ever for a homeowner, because you don't really see it. But let's say it gives additional instructions there to kind of, if you're doing AI processing of this email and you've got additional instructions there, it's going to go and try to find information to make you happy, to find out what's the best discount, and maybe it will go and find that you get a 10% discount if you're somebody that was able to negotiate a 10% discount. That's bad. I just basically lost $1,200 maybe in revenue based on that indirect prompt injection attack that someone might have succeeded with. So those are a couple of things that we want to be able to filter out kind of as our normal input-output filters. But then you also want to be able to have everything run in terms of sensitivity labels and everything else. So let me give you a couple of different new demos in terms of Copilot control system and how it's working at least on the agentic side, and there are also a lot of controls on the Copilot side as well that you've probably seen, but I want to show you what's new here. So Copilot control system, I've been following this since day one. If you've been looking at mechanics since day one, this has really grown up to a lot of different controls here. So first, for agents, you can decide who has access to agents, if it's going to be all users, no users, or specific users and groups. That's just in general for agent use all up. Then you also have different billing and usage policies that you can create that might be based on different teams, departments, and these are going to be based on how you want to distribute the rights to use agents, how they want to be billed, because you want to track those expenses, for example. And then you also have Copilot Studio licensing, which basically gives you a prepaid message pack of $200 worth of licensing per month at minimum. And now in the Microsoft 365 Admin Center, the agent and connectors page gives you like the complete enumeration of all the agents that are in your environment that you build, whether they're built by Microsoft, third parties, if they're blocked or allowed, the apps that they work in, etc. So this then gives you additional context in terms of the agents that are running in your organization right now today. If you select one of the agents, the nice thing is you can get additional information, you can deploy or block it. You can also go into the different users who have access to this particular agent, and you have more operations that you can perform. And if you want to look into, for example, deploying an agent more broadly, you have the ability to specify the users that you want to be using that agent and determining the different groups, for example, end users there. And let's say this agent requires permissions to an API to connect to my sales data or something. Then I can authenticate in. I can use strong authentication to get access to that API level key to get to that information, and then limit access to these three users in this case that were probably part of that same group. And now when I go ahead and do that, these folks have access to the agent that has access to the underlying data. Now I also have message consumption. Again, I'm going to want to look at this by user, maybe by department, so I can see my consumption trends for things like pay-as-you-go services if you're using Copilot Chat with consumption plan and metering. This will show up here, or you're doing autonomous actions using paid Copilot license, you'd be able to see messages here as well, and which users are consuming the most messages, etc. These are all brand new controls that are coming into the Copilot control system as part of your admin feature set. You can see like which agents are developed in-house by Microsoft, third parties. You can also give reports to other stakeholders in your organization using Copilot Analytics as part of Viva Insights, which everyone has access to with a Copilot subscription. So you can actually see like how many hours is it saving? What are the session outcomes? What are the topics that they're contacting us for these agents? IT support, sales support, those types of things. So a lot more stuff. I mean, if you looked at kind of our Copilot management and agent management in day one, there's so much that's happening so quickly in terms of giving you more visibility and more controls. Now for Microsoft Purview, there's also a ton of updates there where we're basically saying at any level for any agent, we can see if there are any things that, for example, are working with sensitive information, risky activities through insider risk management, communication compliance matches, those types of things with the agents that you have deployed. Again, these are things that you can build a bit of them maybe if you tried to use the connector with ChatGPT and Purview, which there is one, but all these are native. So the audit log, for example, is auditing and logging all of the interactions with any agent or any Copilot interaction. Those are used in things like insider risk management, like you can see here. They're also used in terms of communication compliance, where you can see not only the prompt, but a lot of even the responses that were made by your agent or in Copilot. The same thing with e-discovery. So you have the ability through e-discovery to actually create cases using the data that's part of those Copilot interactions and those agent interactions. So you've got all that fidelity there. So I didn't want to end, though, on all the different things in just security and compliance, because there's a lot of updates that we just made on the 23rd of last month, in the last week or so, that I wanted to show too, in terms of all the updates that are being done from a kind of user interface and how you would interact with Copilot and Copilot Chat and all the other tools. So first off, with Copilot, we've added a lot of navigation to the left, where you can get to search, like I talked about earlier, analyst, researcher, all these different agents, the ones that you pin, the create experience that you might have seen, and your prompt itself, it's going to have a more streamlined set of suggested prompts. The prompt is above the suggested prompts now, so it's more front and center, where you can add content. And this is another thing everything's built into Microsoft 365, so I can use a / get to files, people, meetings, emails. The more actually is sites and other, so Power BI, for example, or third-party things that are in Microsoft Graph, you can actually connect to those there. Now, you can also create interactive charts and things through Copilot, so it's getting better in terms of interactions on the page and the canvas. Now with search, this is where I mentioned not only do we have kind of the quick access and things that you're used to from a Microsoft 365 perspective, the search is using hybrid vector search. They'll say AI native search, but what does AI native mean? It means hybrid and vector and re-ranking and all of those things, and also keyword support. And it will give you not only the results that it finds that are semantically and keyword best matched based on the re-ranking, but also third-party data that you've connected up through the graph. It will find that as well. And so you can actually have it work across not just your Microsoft 365 content, but anything that you connect to Microsoft Graph. And it will summarize the results as well as part of what you get back from search. Okay. This gives you also, when you look at any files, a summary of that you can get without even opening the docs. One of the best things is the create experience, where we'll actually give you kind of the GPT-4o image generation as part of this, in addition to other things like being able to write a draft with a very stylized template in, for example, Word. You can do basically image editing, where you can do removal of objects from an image, or change the coloring, the vibrancy, or do background removal, those types of things, all built in. So if we look at one of these and what it looks like actually running, if I submit my prompt that I want to create a shoe ad, for example, and then select my shoe, kind of similar, you might have tried some of this in some other tools before, but basically you can choose your lighting, you can choose your brand kit, and the brand kit's a big deal because you can get your logo, your color palette, all those types of things, and it will generate a on-brand image with your logos, like you can see here, of what you want to generate. Then you can add additional transformations if you want to, say here, like I want to add ground cover with moss and rocks. I can then go in if I want to do things like background removal or change backgrounds, blur backgrounds, those types of things. Here I want to get rid of a couple items in my ground cover, and it will go ahead and it will do that with removal. I can add text to it and then kind of edit the text, and then have a downloadable image. So these are all things that are part of what's coming to the updates for Copilot. Now, my favorite thing is actually personalization and creating custom instructions. So you can say, like, I do technical audience stuff, and I run the mechanics program at Microsoft, and I want to speak in this certain way. You can actually give it those types of instructions to where the responses are more predictable. And then, in terms of going into memory is still using RAG, by the way. It's not ingesting it into the large language model. It's basically taking a handful of facts. I like to go to Australia for the holidays. I've got a cat. I'm going to Vegas for the community conference. All these things, and it will bring those up basically as part of your initial prompt in another session next time you spin up a session. So you can also basically control what memories are being stored of you. These are, again, little kind of factoids of things that it knows. So it can say, hey, Jeremy, how was your trip to Germany when you went and did this, the trip around Germany over the summer? Those types of things. And again, you can control whether you want it turned on and what memories it stores of you and what it has back there. So all of this then, this is the roundhouse of all the different things inside of Copilot Stack. So hopefully this was enlightening in terms of some of the things and how things work and how we've worked around different engineering cases. Of course, you've seen all the different enterprise AI commitments that we have across the board and all the things that we're doing there. In terms of like being able to get more information like this, we've got a couple of great sites, adoption.microsoft.com, if you're looking for that to get it Copilot adopted even further in your organization. And I'm not closing here though, I've got something else. Anybody else want to see an encore performance of the multi-agentic ad creator with narration? All right, I've got that one coming up. So a lot of community content. The encore, Contoso Cola. All right, I love this one. So you have to look closely because there's a couple of things that aren't quite physics correct in terms. This one I didn't give it any images. So the first one I gave it images of SUVs with like an overlander tent on the top. But watch this closely and you'll see some things. Pay attention to the guys that are driving the car and the car itself. Okay, so this time we gave it a prompt that said, I want to create a 25-second spoken ad talking about how Contoso Cola is the ultimate refreshment for your active lifestyle. Okay, so we submitted that, and it goes and it runs. This is the running code version, by the way. Like, this is literally how it's going to interact with you and run. I cut this down a little bit.
Need
in
a
terms
boost
of
for your active lifestyle? Reach for a Contoso Cola, the ultimate refreshment that keeps pace with your passion. Crisp, bold, and energizing, Contoso Cola is the perfect pick-me-up for road trips, workouts, or wherever life moves you. It's more than a drink. It's your go-to companion for crushing goals and chasing dreams. Stay refreshed, stay unstoppable. Contoso Cola.
Not bad. Thanks for coming today. If you got any questions, please come to the front. And I've got stickers still if you want those. Thanks again.